Okay. Now, yesterday we had a discussion, right? And I told you that I'll show you how route looks, routing table looks on lab, right? How it looks, BGP EVPN table specifically, right? So we have small, basically this is the topology, right? And yeah, if I have to, okay. So 1 minute, let me pull up that topology so that I can show you. So this is the topology. Okay. So if so, this is one client one, right? And client 2, 3 and 4. Client 1 and 2 are in different VLANs. This is, let's say, VLAN particular 10, then this is V11. Okay. And these are all VTAPs. VTAP, this is one VTAP pair, correct? And this is another VTAP pair. Okay. And these are spines. Okay. And this is L2 EVPN, layer 2 EVPN. Okay. So what we'll do is when I ping from client 1 to 2 or client 4, right? Or 3, whatever, right? As soon as I start ping, it will maybe first of all, it has to, if it is a different subnet, it has to send out ARP for the gateway, right? Then ARP is learned. So at the same time, here also we will learn MAC address, right? As soon as we receive any packet from client, we learn the MAC address of the client. And as soon as client sends out ARP request for the gateway, we also update the ARP table for that client, right? So our MAC and ARP table is updated, right? And as soon as EVPN learn this, basically locally MAC and ARP is learned, it will create type EVPN route and it will advertise that route to all the other VTAPs, right? Is it clear? Any question? Okay. So basically, yeah, it will create EVPN route and advertise, right? So now that's what I want to show you here.
Vishal, one quick question.
Yeah.
Can you go back to that
Yes.
diagram?
Yeah.
So in this, when the client, suppose client 1, client 2 are in different subnets, right? Client 1 will send out the ARP request. So will leaf A generate that type 2 route with just the ARP request?
Okay, no, ARP request. So, okay. So when client 1 and you mean to say client 2, right? This two.
Yeah. Or
So
any
client,
yeah.
same VTAP, right? So client 1 sent, oh, sorry. Client 1 sends out the ARP to the gateway. It's learned, send out ICMP packet here, right? Now it will check that destination is another VLAN. So it will route within this VTAP. And now it has to send out ARP request, right? So that will send out ARP request to, this locally as well as to other VTAPs, right? Based on flood list.
Okay.
Okay.
Okay, got it.
Because even though let's say client 1 wants to communicate to client 3, same VLAN 10, right? Then at least ARP request should go read to our client 3 and then ARP reply it has to receive, right? Then only all communication will happen. But what will happen here is, right, let's say client wants to communicate to client 3, it sends packet to the gateway in VLAN 10, right? And client, this is 11, right? Another VLAN, different VLAN we are talking about. So it will route into VLAN 11 and then it has to send out ARP request for client 3 IP to get the MAC. It will flood here locally. It will also send that ARP request to client 3, right? And then due to flood, it will receive here. Now client 3 reply back, right? Now, as soon as client 3 replies back, here also we have VTAP SVIs, right? It will learn the ARP, right? Locally, it will learn the ARP and also MAC. Now that ARP relay reply, right? That is not needed in this EVPN. Why? Because as soon as this guy learns the MAC, right, it will generate routes, EVPN routes. I'm not talking about 2, 3, all that, right? And then it will advertise that to all the other VTAP, that EVPN route, and that MAC and ARP will be learned here to all the VTAPs, right? So that they can able to send the packet.
But it will generate only via ARP reply, right?
Yes. Basically, it should have learned. See, if this client has already communicated to some other device, right? Then that ARP and MAC is already learned here, and then it would have advertised even before that. Then you don't have to even generate ARP request, right?
Okay. So basically, ARP table, when it is populated, that's when it will generate the ARP.
Yes, MAC and ARP. As soon as this any client learns locally, even though they have just sent one packet to gateway or they have sent to any other device, as soon as you learn MAC and ARP locally, you will generate EVPN route.
Okay.
Okay.
Yeah.
Any question? Any other question? So maybe some of you might not understand this because you don't know more about different type of route, how we send this MAC and all, but that we will discuss. Okay. So let me show you now, as you mentioned, you want to EVPN route table, right? So see, this is one host. Okay. So if I do, this is one client, client one. So client one, this is the IP 10.1.10.101, right? So let's check. Show ARP. Okay. What is the IP 10.1.10.101, right? So we have, this is the ARP, right? It shows not learn. Let's ping again, right? Okay, so now it is see 10.1.10.101, right? It is locally learned on port channel. So we have updated the ARP. ARP is updated. This is the VTAP. Okay, this VTAP first, leaf 1A, you can say leaf 1A. Okay, so you have learned the ARP and show MAC address table, right? What is the MAC? 3270 client one. So 3270 MAC is also learned in VLAN 110. Okay. So now, as I mentioned, right, as soon as we learn the MAC table, learn this in MAC and ARP, we generate route, show BGP EVPN detail. Okay. So if I have to check that, basically if I run show BGP EVPN, I would see all this, right? So 3270. So this is the MAC route it has generated, right? And this is the ARP route it has generated. We'll see, means how it, how it basically, how it is reflected and all that stuff. But this is how you will see the BGP EVPN table, right? We have been discussing global table or BGP EVPN table. So this is what is that table. And from here, this route will be advertised to route reflector or spine. In this case, it will advertise to spine. And in MPLS, it will be advertised to route reflector, right? Or P device, P to P. Now, if you want to check more in detail this route, right? So this is the command detail. And then you will see that, hey, this MAC 3270, right? We have been discussing it will add route distinguisher to make this route unique. So this is how it will looks. It looks like that this is MAC address plus route reflector. This is RD value. This much is the RD value, this big. Okay. So it has combined MAC plus RD, right, to make that route unique. Okay. And that you should see here also, right? Route RD and MAC, right? To make this route unique into this routing table, correct? EVPN table. And then it also adds route target, right? Export, and then other information, which we will discuss later. But this is how it will generate this route. Okay. Similarly, it also generates ARP, route for ARP, which is MAC plus IP, right? So this is one, along with route distinguisher, and add also route target, also sends route target, right? So this is how your BGP EVPN table looks like. Okay. If you see here, there is one more information or route, different type of route, which is called IMAT route. This is nothing but for flood list populate, right? So if this particular leaf 1A, so run interface VXLAN 1, right? So it has this, it is part of VLAN 110 and 111. So it has to advertise its own VTAP IP, right, to other VTAP, so that they can include this for both this VLAN. It can include into their VTAP flood list, right? So that's how we will advertise that using this route. I'll explain you means how, what is the format and all that, but I just want to show you that how we advertise MAC route, ARP route, and flood list, right, to other VTAPs. So this is how we advertise that. And along with this, we also send out route target for that flood list information also. So this is flood list, right? And we also send out route target along with RD, same as MAC, what we have seen. Okay. So basically, this is how, you know, BGP EVPN table looks like. Show BGP EVPN table, global table, right? And the spine. So let me log into spine, one of the spine. It should be 8, I think. Okay, what happened? 1 minute. Yeah, spine is 2. Oh yeah. Admin. So spine also a similar table, BGP EVPN table, right? But if you check show VLAN, so MAC address or show ARP, it will not be there, right? On spine. And this does not need to, because leaf 1 will, it will point out to the other VTAP IP address, right? The next hop will be other VTAP IP address. So if I have to show you the next hop, as we discussed, right? 255.103. So this is locally generated, and this is what the route MAC we received from other VTAP, right? And that points to other VTAP IP address. This. So this is the spine. Via spine, you received this route, but the final destination next stop is 254.4. So you will encapsulate the packet with this VTAP IP. This is the VTAP IP of another leaf, this leaf 2A and 2B. Okay. Okay. So any question if you have not understood how this looks like? Don't go in more detail, that we will discuss, but just wanted to understand how it looks like in leaf and spine. Okay.
Vishal, one question. So in this ARP table on the leaf 1A, right? We see, let's check, like ARP entry for .101. It says not learned, but the table is populated.
Yeah,
is this
because
from the cache?
No. Okay. So see, basically, if you see here, it was not learned, right? Why? Because MAC aging timer is 5 minutes and ARP aging timer is 4 hours, right? So because I pinged 10 minutes back, it learned MAC during that time and then it flushed out. That's why I just ping now, so that it MAC again learned again, and now it is reflecting as learn, right, from port channel 5. So
got it.
yeah, so it's because of MAC and ARP timeout is different, default timeout, right? But yeah, we have to make sure that customer configures ARP timeout should be less than MAC address or equal or less than. Okay, otherwise it can create flooding of traffic. Yes. So that also we will discuss when we'll come to troubleshooting. Just remind me. But that it can be a common issue. So they should configure Mac and ARP as same time, or at least ARP should be less than Mac timeout. Okay.
Okay.
Okay. Any other question? Okay. So now let's
Vishal,
yeah, Victor.
looks like I forgot the RT because I remember when it's coming to sharing of prefixes, we are still using that when sharing of app and Mac.
Yes. So if you remember what we discussed, 1 minute, we did discuss layer 2, right? Type 1 minute. So this is okay. This is okay. Yeah, I think. Oh yeah, this one, right? This is what we discussed yesterday. MacWaf.
Okay.
Yesterday means in last session. So
yeah.
so let's say. So let me. Yeah. So this is the host 1 and Mac A, right?
Yeah.
As soon as you send out any packet to your gateway, VTAP 1 is the gateway for that VLAN. Okay, VLAN 10, let's say.
Yeah.
As soon as you send any packet, you learn the local MAC, right? Local MAC, MAC A, and also R for this guy, right? So MAC A, and also you learn the R locally, right? The way we have seen here, right? MAC and ARP is learned. As soon as you learn the MAC address, let's talk about MAC right now, right? To avoid kind of more complication. So you learn the MAC locally A, right? What you do is you add route distinguisher RD value, right? From where? So this is the configuration for that. For VLAN 10, you have to add RD of 1:1, right? So you have configured this under your BGP. So now as soon as you learn this in Mac under VLAN 10, you create route, EVPN route, you add RD value. So now your route will be MAC A and RD this, right? So this is your one route with RD, right? And then you have to advertise it to the spine device, right? Or finally you have to send it to VTAPs, other VTAPs, right? So now when this is your RD plus MAC A, right? One combination, which I have shown you here. Okay, yes. So this is the one, right? RD plus MAC combination, right? Or if I have to show you in detail, MAC address and RD, right? We combine both of them to make it unique. So this is the route, that route, okay? Which is this. Now, when we send that route, right? So this route will be first put into the EVPN table, like here. So this is local route, right? It is put into your EVPN table. Once this is your local MAC, you generated EVPN route, right? By adding RD value. And also you combine with route target value and you put it into your BGP EVPN table to advertise it. So this is how it looks like. Okay. So same way here, you added RD value, right? And also now you check that, hey, for this VLAN 10, what is the route target export? So it is 100, right? So what you will do, why man? Okay. So route target export is 100, right? So you will also add route target of 100. So this is your one EVPN route, right? Where you have MAC A along with RD and RT. And this is how it looks in EVPN table, which we have seen here, right? MAC, RD and RT. So this combination is what you have locally in your EVPN table, right? BGP EVPN table, and then this will be advertised to other peers VTAPs through spine.
Okay.
Is it clear?
Yeah, it's clear.
So to answer your question, right, for MAC, basically for MAC, ARP or route, right, everything for everyone, every information sharing, we will add RD and RT to distinguish at other end. Why we have, okay, now can anyone tell me why we have to do this for MAC as well? What is the reason?
So that we get to, is it because when you get to VTAP 2, we learn it in the correct VLAN?
Yes, right, because when you receive it here, right, you first again you will save it here in your EVPN table, right?
Yeah.
So if I have to show you it on this, right, let's go to the another, yeah. So 4, 2, 3, 4, 5, 6, I think, yeah. 6 is another side leaf, right? Admin, which is leaf 2A. Show BGP EVPN detail, right? What was the MAC? 3270, right?
Yeah.
So let's check 3270. There are many routes. Okay. There is command to specifically look particular, okay, let me ping again. Maybe that MAC is expired, right? So okay, routing, yes, this one, right? See, 3270, right? Route distinguisher, correct? That route distinguisher which we have sent with, correct? And route target. So we have received this route through spine. Through this VTAP has sent that to spine, and spine forwarded it to here, which you can see here. This next hop, this 254.3 is what? This IP address of VTAP. Show run interface loopback 0, right? VTAP IP address, right? So it's pointing that, hey, to go to this MAC, send packet to this MAC, you have to send packet to this VTAP, so that you will encapsulate with this VTAP IP, outer IP. Via this route, you received ultimate next stop is this VTAP, but you received it through this spine. This is one of the spine. There are 2 spines, so that's why 2 next stop, right? And then it also says that, hey, route target is this, right? So that you install this route. So based on this route target, right, this guy will run sec BGP, right? Let's check that route target, right? What you are looking for, 10.110.10.110 belongs to which VLAN? Route target VLAN 110, right? So now if you check here, show MAC address table, that MAC 3270 is learned on in VLAN 110, right? Over VX1. Is it clear?
Yeah, it's clear. And
yeah.
So if you go up to the RD again, scroll up to that 192.168.255.3, that what was that?
That is the RD value configured here. Show run sec BGP. This RD value.
Okay.
So this RD value and this route target, which we can see here, because it combines that both, right?
I was a bit confused because I was expecting the RD to be like what you're seeing 1.1.
Oh, yeah. So for in presentation, we use not simple one, but here, yeah, it's big one like this.
So,
which also,
and is that the route under BGP? Is that the BGP route ID?
Which one?
The one we put there in RD.
This one?
Is that is that the BGP route ID or is that
route distinguisher? It is route distinguisher, RD.
Okay, but the combination there we put
combination. Yes. Router ID plus any random, So basically they have combined router ID and VNI. So this is your VNI.
Okay, yeah, got it. Yeah, thanks.
Yeah. So this is VNI. So they have combined RD router ID plus VNI, and for VLAN 111 router ID and VNI. Okay. Okay, but don't worry if you have not got, because we'll discuss all this in more detail. This is just to give you, as we came to this, I thought I'll show you. All right, but that's we'll discuss this everything in detail, right? Each of this field we'll discuss. Okay. So now with that, let's move to the one which we wanted to start today, right? But before that, any other questions? Okay, so let's start. So there are different L2 VPN, right? This is all what we are discussing, right? MAC information pass, passing R, basically L2 VPN, L2 VXLAN or VLAN to VLAN communication. That is called all L2 EVPN, right? And there are different service model for that. Different ways we can configure L2 EVPN. Okay. So one is VLAN base, right? Which we will discuss next. Then another, there are three. First is VLAN base, VLAN bundle, and VLAN aware bundle, right? So now we will, discuss each one of this, right? And what is the difference between them? So let's start with VLAN base service. Okay. So VLAN base service is nothing but it's something. Okay. So this is your one VTAP, right? You have one host, right, which is connected here in VLAN 11, and another host is VLAN 10. So you have two VLANs connected to VTAP, this VTAP. What you do is, for each VLAN, you are creating separate MAC WAF, and same as separate EVPN instance. Both are same, separate MAC WAF and EVPN instance. What does that mean? For each VLAN, you have separate route distinguisher and RT value, route target value. So for VLAN 10, you have route distinguisher, let's say RD1, then an RT is 1. So for another VLAN 11, you have separate RD2 and route target 2. This is same as what we discussed, in earlier example, right? This. For both VLAN, we have separate RD and RT value. So what we have so far discussed this, right, scenario is VLAN base, right? And this is the configuration. Your VLAN 10 has RD and RT, which is different from another VLAN, RD and RT, right? So basically idea of VLAN based model is what? If you have 100 VLANs, right? If you have 100 VLANs, each VLAN will have different RD and RT. VLAN 1, 2, 3, 4, 5. Each one has different RD and RT values. In short, if you have to say, you have to create 100 MAC WAF, right? One MAC WAF is what? It's a one pair of RD and RT value associated with that VLAN. And the configuration is what I have shown you, right? So if you have 100 VLANs, you need to have 100 RDs and RT values, right? For each VLAN separate. Now, why we need to do this? Because as we discussed, right, when you send this packet with combining RD and RT value, right? So this is, let's say, MAC A, and when you receive here on this VTAP that route information in EVPN table, right, for MAC A. So what is the information? A with RD value, right, which is 1 in this case, and RT value 1. So you receive this route here on this VTAP. Now you have to install this MAC into your MAC table, right? And now to install that MAC into your MAC table, what you will check? What you will check to understand that, hey, this MAC belongs to which VLAN?
RT.
Route target, right? So because route target, whatever route you have received is with 1, right? And same configuration is here also, that for VLAN 10, RD is 1. and route target import export both is 1, right? So you understand that, hey, this route has come with RT1. That means this belongs to VLAN 10. So you will put this VLAN 10 and MAC A here, right? So this is how you will learn. Basically, at other end, you will understand that this VLAN belongs to which VTAP, this MAC belongs to which VLAN based on RT value. And that's why for each VLAN, you need to have different RD and RT values. Okay. Is it clear? Any question? Any question on what is VLAN base, right? What is MACWF, different MACWF, and why we need to have different RD and RT values in VLAN base? Okay. Now, one more thing is, for each VLAN, you also have to configure different VNIs, right? So VLAN 10, VNI is 1010. VLAN 11, VNI is 1011. So you also have, if you are configuring VLAN base configuration L2 VPN, you have to configure, obviously under BGP, you have to configure VLAN 10 and all that, right? All this, what we have seen before. This. But you also have to configure this, right? This is in next slide. This configuration, that VLAN 10, VNI 1010, VLAN 11, VNI 1011, right? Now, can anyone tell me why we need to configure different VNI as well for VLAN 10 and 11? Why we need to have different VNI, or even in VXLAN, right? This is VXLAN, right? So in VXLAN, we configure different VNI for different VLANs, right? VLAN 10, VLAN 11, different VNI. Why? So how it is?
Identification of the VLAN.
Yes. So can you tell me this VNI information will be in which part? Where you have to want to identify? Control plane, data plane?
In the VXLAN header. It should be.
It should be in
Should,
data plane, right? Okay, so let me explain you the whole picture, right? How this will work. Okay, so let's discuss that. Okay, let's say this is one host A. Okay, host A in VLAN 10. Okay, 10. There is host B here, VLAN 10. Okay, you are pinging from host A to B. Okay. I am just thinking, should I take different VLAN or same VLAN? Okay. ARP everything will. Okay, let's go with this. So now what will happen is, host A wants to communicate with host B, right? As soon as it sends out any packet, right, it will learn here the local MAC. So MAC will be learned here, local MAC A, right? A for VLAN 10, right? As soon as it learns the MAC, I'm right now only discussing MAC. Okay, let's not discuss ARP right now. We are learning MAC, right? As soon as we learn the MAC, we'll create EVPN global route, right? For this MAC A, we'll add RD. So my global route will be MAC plus RD, right? Which is 1. And I will also send out RT of 1, right? Route target 1. Okay. So this information is first learned here in global table, and then it will be advertised to the other VTAP through spine or other devices in between. Spine receives this into its global table, right? Same route. It checks the route target, which is what? 1, right? So route target is 1. So it understands that, hey, VLAN 10, that configuration, right? VLAN 10, RD1 and RT import export both one. So based on this information you configured under router BGP, it understands that, hey, this MAC A belongs to VLAN 10. So it will update its table, right? That VLAN 10 and MAC is A. Okay. And what is the interface? Interface VX1, right? It updates this, right? It also updates VXLAN address table, right? Address table. So what information it will have? VLAN 10, MAC A, and VTAP IP address. Let's say this VTAP IP is 1.1.1.1, right? So it updates that, hey, do you want to send this packet to one VLAN? Basically, you have to send to VTAP 1.1.1. This host A is behind VTAP 1.1.1. So this is where EVPN will, this is all control plane, right? You updated, basically you generated learn local MAC. As soon as you learn local MAC, you created this route, right? EVPN route. You advertise that EVPN route. Here also you received in EVPN route, and based on RD/RT value, you populated VLAN and VXLAN table. So this is control plane, EVPN control plane, right? We have not yet started ICMP. Basically, this is all learning, right? Based on MAC table. So this is all control plane. Now let's talk about actual data, right? Let's say B wants to send packet to A, right? What it will do? B will send packet to the VTAP, right? First of VTAP. VTAP will check, hey, how to send packet to A. Destination MAC is A. So it will check, hey, MAC A, and also it received on VLAN 10. So it will check, hey, for MAC A, it belongs to VLAN 10 and it is over VX1. So I have to send it over VX1 interface. But to which VTAP? So it will look into the VXLAN address table. Now this is all data plane is all VXLAN concept. EVPN is not there now. Okay. EVPN was only used for control plane. Okay. That is to learn. Once we populate this information, which we used to do it using HER, hidden replication, or CVX, right? After that, EVPN does not come into play. Okay, EVPN is only control plane. The purpose, the way CVX was, populating this table, now EVPN is doing. So now EVPN is not in picture. Now it's pure VXLAN data plane. So what we do is we check that, hey, MAC A is behind VTAP 1111. What we will do is this will encapsulate the packet. Outer destination IP is 1111. Outer source IP is 2.2.2.2. This VTAP IP, right? It will add the VNI information, VXLAN header, VNI, whatever VNI we have configured under interface VXLAN 1 for this VLAN, right? Interface VXLAN 1. So for this VLAN 10, we have configured 1010 VNI, right? So now it will add that 1010 VNI as well, right? Into VXLAN header, send it to this VTAP. This VTAP will decapsulate the packet, check the VNI, which is 1010, which belongs to VLAN 10, and forward that packet to this host A. Okay. So the point here is for control plane, right? EVPN, we are using RD and RT values, right? To forward the packet. And we will also send this VNI information in RD and RT, basically in this route update. I'll show you, I'll tell you why. But this VNI will be utilized for data plane traffic, right? To identify when data comes in data plane, you don't add RD, RT or any sort of stuff, right? You add VNI, and based on VNI, you will understand, hey, this packet belongs to which VLAN, and you forward that packet, right? So in VLAN base, we have separate RDRT, MACWOF, and also separate VLAN to VNI information. Any question? Are you clear now? Means basically what is control plane, what is data plane, and how it takes means how it falls into this? Let me know if you have question or doubt, I can explain again.
It's more clear now.
Okay. Anyone others? Are you good with this? Okay.
Yeah.
Okay. Okay. So this is how it looks like. So this is a more, in detail diagram that where we learn this MAC table one, right? We added RD and RT value. So on based on what we added this RD and RT value. So this is the config that for VLAN 10, we have to add this RD and this RT, right? Export RT. So we have added RD and RT value, and we will advertise this route, which is nothing but this, what we have shown you. We checked, right? So this is your MAC address, right? Local MAC address, this MAC address you learned. This is your route distinguisher you want to add for that VLAN, right? This is the route distinguisher. And along with this route, you will also advertise route target, right? So this is the route target, right? Which you will advertise, right? And I also told you that, even though for this information, right, EVPN route, when we receive this route at other end, we just check the route target, and based on that, we know that, hey, this route belongs to VLAN 10, right? And we install, update the MAC address table based on this. We don't use this VNI, but still we send out this VNI information as well, okay, into the EVPN table update. Okay, but we will just check this route target, and based on that, we will install this route basically into basically MAC table update based on to understand that this MAC belongs to VLAN 10. Okay, so this is the different configuration. So VLAN 10, this is one MAC WAF, VLAN 11, another MAC WAF, right? And then VXLAN configuration, which we used to do, right? VLAN to VNI mapping, and this is how route will exchange. Okay, any question? So basically in VLAN base, everything is unique for each VLAN. VLAN 10, MAC WAF, basically RDRT is unique, and also VNI is unique, right? So everything is unique for each VLAN. So one of the drawback of this is, let's say your customer has 100 VLANs, right? They need to configure 100 RD, RT, and VLAN to VNI mapping, right? So that's, and if there are more VLANs, you can understand how much configuration and RD, RT will be there into this, right? Any question? Okay. So this is VLAN base, right? One-to-one mapping between VLAN ID and MAC WAF, right? VLAN ID and MAC WAF. So one VLAN 1 has MAC WAF 1, VLAN 2 has MAC WAF 2, and MAC WAF is nothing but combination of RD and RT, right? Okay, VNI carries MAC WAF information as it has one-to-one mapping with VLAN ID, right? VNI is also again one-to-one map with VLANs, right? The one-to-one mapping also means that route target associated with MAC WAF, route target with MAC WAF uniquely identifies the VLAN at other end, right? So based on route target, you can understand that this MAC belongs to which VLAN, right? To import that, update that MAC table. Okay. So this is VLAN base. Now, as we already discussed here, right? The drawback of this is if customer has 100 VLANs, you need to have unique VLAN, MAC WAF, RDRT, and VNI information, right? For each of this VLAN, which is for bigger network, it's difficult, right? So next is VLAN bundle service. Now what you have done here is multiple VLANs, right? VLAN 100, 200. For all these VLANs, or let's say there are 100 VLANs. For all VLANs, you have only one MAC WAF, only one MAC WAF. What does that mean? For all these VLANs, 100, 200, you have single RD and RT, only one, RD1, RT1. Now, can anyone tell me what can be the problem in this case? And even VNI is also same. If you see here, VNI is also same for all the VLANs. Now, what can be the problem?
Flooding of traffic.
Sorry?
Flooding of traffic, like there's no segregation between VLAN 100, 200.
Yes. So let's say here you have VLAN A, right? MAC A into VLAN 200. Let me first clear all out. Okay. So this is VLAN 100, you have MAC A. Okay. VLAN 200, you have MAC B. Okay. Locally learn. As soon as you learn locally, you add RD/RT. So you add MAC A, RD is, let's say 1:1, only same, right? 1:1. And RT is also 1:1. Similarly, MAC B, right? MAC WARF is same, means same RD/RT for both the VLAN. So again, 1:1, 1:1, right? You send out both this to VTAP2, both route. Now, based on route target, it has to install, it has to determine that, hey, this MAC B and A belongs to which VLAN, right? VLAN and MAC A and B, which VLAN? Can you tell me? We can determine because both are same RT, even though they are belongs to different VLAN, but same route target. So can we determine which VLAN it has?
Not with the information that we have.
Yes. So basically we have confusion, right? Whether it belongs to VLAN 10 or 20, both MAC A and B, right? Because that information now, all VLANs to solve one problem, right? To avoid multiple WAF or multiple RD/RT for each VLAN, we we made that, hey, let's use same RD/RT. But then there is another problem, that how we'll determine this, right? Different VLANs when we have to update the MAC table, right? So VLAN bundle is basically that to use same RD/RT for all the VLANs and also same VNI, right? Now to identify that, right? It also adds the Ethernet tag. Okay. So when we send out this update information, it also add the Ethernet tag, which is nothing but for VLAN 100, Ethernet tag is, let's say 100. And for 200, let's say Ethernet tag is 200. So that in all information is also added into this, right? In this, and because of that Ethernet tag value, you would be able to identify whether it belongs to VLAN 10 or 20. So now you will refer Ethernet tag, not RT, to understand this belongs to which VLAN. Okay, so that is so basically multiple VLAN are part of same MAC WAF, right? Same MAC WAF, same RD/RT. So because of that, route target associated with MAC WAF identify customer. Basically, it identify particular customer, but not the VLAN, right? Does not identify individual VLAN based on route target, right? So basically that's why we use Ethernet tag. The VNI label in route only identifies the EVI in the VXLAN forwarding table. Then therefore the original VLAN ID Ethernet tag is retained in VXLAN encapsulated packet. So even because you are using only one VNI for all the VLANs, right? All the VLANs, even for data plane traffic also, where you identify using VNI, which is same, right? When data comes for with this VNI to this guy, you won't be able to say, hey, it's a VLAN 100 or 200 because it's same VNI. You also have to send in data plane traffic also, you have to add Ethernet tag, which will identify that this data plane traffic is for which VLAN, right? So basically in forwarding also, you have to add Ethernet tag, right? So that you can identify this. Now, there are few issues with this. So one is because this is a one single verb for all the VLANs, right? The limitation is you should have unique MAC address for each VLAN. So that means you can't have MAC A learned on VLAN 200 and same MAC A learned in VLAN 100 also. That is not possible with this particular VLAN bundle service. So you should have unique MAC for each VLAN. Another is your traffic, because all VLAN is part of same MAC verb. If you have ARP request received, right, for VLAN 100, but that will be advertised to all the flooded into all the VLANs because it is part of same verb, MAC verb, right? So basically traffic will be flooded to all the VLANs into that MAC verb, right? And because of all this limitation, Arista do not support this VLAN bundle service. Okay. So this is VLAN bundle service where for all the VLANs you have same MAC verb, same RDRT and same VNI. And because of that, you need to add Ethernet tag into control plane as well as in data plane to identify that VLAN. But that this has some limitation because of same MAC verb and same VNI, that bump traffic will be flooded across all the VLANs, right? And also MAC should be unique for each VLAN. Any question in this? Okay, so next is VLAN aware bundle service. Okay. Now, in this, for all the VLANs, it is same MAC verb, one MAC verb. Okay. Or you can have that VLAN 10 to 20, 10, 11, 12, 13. VLAN 10 to 20, you can have one MAC verb. One MAC verb is one set of RDRT, right? RD1, RT1. Sorry, RT1, 1. And for 21 to 30, another VLAN, set of VLAN, you can have another MAC verb with RD2 and RT2. So basically, you can divide all the VLANs into group of multiple MAC verb, right? So multiple VLAN is part of same MAC verb 10 to 20, right? One which has one RD and RT value. Now again, problem will be same what we saw in previous one, right? That when this route comes here, because all VLANs have same route target, we won't be able to make sure, hey, this VLAN MAC belongs to which VLAN. So to solve that problem, what they have done differently than the previous one is they kept different VNI for each VLAN, which was same in the previous one, right? So VLAN 10, VNI is 1010, VLAN 11, VNI is 1011, VLAN 12, VNI is 1012, right? So now because, and this information also we are sending with route information. If you remember, I showed you that, right? So here, as I mentioned you that we also send VNI information, but for VLAN base that is not needed, right? Because route target is already different. So based on that, we are able to make sure install it against particular VLAN. This MAC belongs to VLAN 10 based on route target, we were able to determine. But now because for VLAN 10 to 20 all has same route target, we will check VNI information, right, to install that route into for that particular VLAN, right? So the difference here is you have separate VNI, right? And which will help you to determine this particular MAC, let's say MAC A, right, and MAC B. Both are sent with same route distribution and route target 1, 1. But here you are also sending VNI for MAC A is this, right? This is MAC A VNI. And this is VNI B, MAC B VNI. So when you receive this route, you check the VNI, and based on that, you will understand that this VLAN 10, this MAC A belongs to VLAN 10 and MAC B belongs to VLAN 11. Is it clear? Any question? Okay. So now just last part of it is this, right? Configuration. So this is the configuration. VLAN to VNI is different, right? Which was there for VLAN base as well. But this router BGP configuration is different than VLAN base. Now, if you see here, VLAN aware bundle, VLAN 10, 11, we have combined two VLANs, which has one RD and RT value, right? So basically two VLANs we have combined and it is only one MAC WAF, right? Single MAC WAF and same RD/RT value. So that's what we see here, right? When we send out this MAC information, right? This MAC address, right? This MAC address, we add same route distinguisher, right? But if you notice here, we are adding this VNI also here to distinguish, make it unique MAC IP, MAC, right? So 1010 we are adding here and also it is here one in VNI. So this will help us to at other end to make sure when we receive this other end receives this route, this 1010 will tell us this MAC belongs to which VLAN because RD and RT is same for both VLAN 10 and 11, right? So this VNI will tell us which MAC this MAC belongs to which VLAN. Okay. And if you have noticed the previous output, right, VLAN base output, this 1010 was not there in that output. See, it was not there, right? So when you use VLAN aware bundle, you also add here that VNI. This. And also obviously it is here. Okay.
Hey, Vishal, any reason why we have it twice? Because we would still have identified it, right?
Yeah. So I actually, yeah, I don't know why we have both here, but I think we can check in. Maybe I'll configure VLAN aware and we'll see how it looks like here, right? Actual route. Okay, yeah, that will look here also same way. Sorry, this is a same output from that only. But I think, yeah, let's check a Wireshark. That will give more information on that. Okay, so we'll have Wireshark with VLAN aware to see which field it has, right? Maybe I think this in output it is showing here as 1010, but I don't think in Wireshark we have separate field for it. It is only included in VNI. So maybe in our output we might have added, which is as per our implementation, but otherwise it is not needed duplicate. Okay. But yeah, we'll see the Wireshark. Okay, so any question? Okay, so fine, then I think we can stop here.